We're going to start by defining what is a polygon. So a polygon is going to be what they call a closed figure, just meaning it can't have any like open gaps in it. All the vertices need to be touching, okay? It's going to have 3 or more, so we're going to write 3+ segments or sides. And those are going to intersect at their endpoints, what we call vertices. All right, so we're going to draw sort of a random polygon. Okay, this is polygon A, B, C, D, E, and generally when they're labeled, they'll either go clockwise or counterclockwise, but you kind of have to stay in order with the vertices. You can't jump around. You couldn't call this polygon A, D, B, E, C, okay? And it makes the most sense to go alphabetically, right? So if you have a choice, you're looking at it, don't start with D, start with A, okay? And if going clockwise makes it more alphabetical, then go clockwise, okay? So just try and make it as logical as possible, all right? Every once in a while, they'll go out of order, but usually they're in order or they'll spell a funny word, okay? So polygons have things like this. This is called a vertex, which the plural is vertices. If you have more than one, okay? Inside of a polygon from one vertex to another vertex, so if we connect D to B over here, this is called a diagonal. Sometimes they're solid like that, sometimes they're dashed. Just depends on whether, sometimes whether it's in black and white or which textbook you're looking at, okay? And then there's these things, which are called sides. So this is side DE, okay? All right, so we're going to draw what are definitely polygons and what are not polygons, okay? You're going to see on your assignment a couple pictures and they're going to say, is this a polygon or is this not a polygon? And you're going to need to say, yes, it is, or no, it's not. And they might even say, why? Why is it or why is it not? Okay? So let's just start with your basic like rectangle. Has 4 sides, which makes it a quadrilateral, right? All of the vertices and sides are touching with no gaps. It has 3 or more segments, okay? And it intersects at all the endpoints, okay? You guys have been seeing these probably since kindergarten, right? Okay. Triangles are definitely polygons. And then octagon is a polygon. Okay. These are all examples of polygons. How many could I put over there? Multiple. And then more, right? Like an infinite amount of polygons. We could keep drawing tons and tons of polygons. Okay, because once you think you have one that has the most amount of sides, there's another one you could throw in another side. So that's like an infinite amount of polygons out there, right? Here's what are not polygons. A circle, not a polygon. Why not? No sides, no vertices. Can you put a diagonal in there? Nope. I mean, you could, but it wouldn't go from vertex to vertex. It would be called something else, okay? This is not a polygon because at this vertex right here, how many segments are coming to it? 4. You see 4 segments coming to that vertex right there? This is really 2 polygons stuck together, okay? So if you separated them, each of them would be a polygon, but together they're not a polygon, okay? And then something like this, not a polygon. Why not? It's open, has a gap, okay? All right. So the polygon that we started with, notice that some of the sides are shorter and some of the sides are longer. Some are medium. They're all kind of different lengths, okay? That's what we call an irregular polygon, okay? So the question is, what makes a polygon regular? There's going to be 2 things that make it regular. Anybody want to guess? Same lengths. All the sides need to be the same length. In geometry, we call that what? We did it with the triangle. I keep hearing equilateral. Oh, bless you. All the sides are going to be equilateral, like an equilateral triangle. We've already learned about that one, right? So if a polygon has 4 sides, can you think of a 4-sided polygon that's equilateral, or square, okay? Or a rhombus, okay? But there's a second qualification that makes a polygon regular. Anybody want to guess? So you remember with the triangle, if it was equilateral, it was also equiangular. Equiangular. Okay, so all 4 sides are going to be congruent and all 4 angles will be congruent. If it's a hexagon, so it has 6 sides, all 6 sides are going to be the same length. All the angles are going to be the same length. All right, there's another term you need to know about in with polygons. It's called concave versus convex. Okay, and sometimes instead of using the term convex, they'll say not concave. Just depends on the book or the however they want to say it. So concave has this little word in it that's cave. Everybody see the cave in there? So that's when you have a polygon that goes in on itself. So like here, it's going to go in. It's going to create this little cave going inside. Anything that goes in somewhere. Any of you have ever seen like a bear cave goes, it's like the mountain on the outside and then there's an opening and you can go in it, right? Okay, so think about that. Versus convex, this pen is dying, does not go in on itself and looks a little more like that. I'm going to move this up. You'll see it in just a second if you're still writing. There it is. All right. So what we're going to talk about next, you're going to see on your chart. And when we're done, you'll be able to fill in all of that chart. So the first thing we want to talk about is the number of triangles within a polygon. And so we're going to start with the easiest one. We're going to start with a triangle. And this one's so easy, it's hard. Basically, how many triangles are in a triangle? One. Okay. So then we're going to start adding some sides. So we're going to draw a four-sided polygon. We're going to pick a vertice. I like this one right here. And I'm going to draw as many diagonals from that vertice as I can. Can I draw a diagonal from this vertice to this vertice? No, because it would be right on top of the line. Can I draw a diagonal from this vertice to this vertice? Yes. I'm going to dash it in there. Or you can make it solid. It just kind of depends. Can I draw a vertice or a diagonal from this vertice to this vertice? No. So I only drew one diagonal, which creates how many triangles inside? Two. We've got 1, 2. Okay. Now let's draw a five-sided polygon, which is a pentagon. And I'm going to pick any vertice. I like the one up top. And from there, I'm going to draw as many diagonals as I can. I can't go from here to here, but I can go from here to here. So that's going to be my first diagonal. There's one. And I can go from here to here. There's 2. But I can't go from here to here. So I've got 2 diagonals inside of that pentagon. How many triangles does that create inside of the pentagon? 3. 1, 2, 3. Okay. The next one is really hard to draw. So hard to draw that we're not going to draw. We're just going to write that it's going to have 99 sides. Right? Anybody think they can draw that? Mm-hmm. Yeah. Okay. So on a 99-sided polygon, which probably has some special name that I don't even know, but you could probably Google it and figure out what its name is. How many triangles would I be able to put inside of a 99-sided polygon?
33.
What? No. More than 33.
45.
More than 45.
66.
So how many sides did this triangle have? 3. How many sides did this quadrilateral have? How many sides did this pentagon have? 5. So inside the 5-sided polygon, there were 3 triangles. Inside the 4-sided polygon, there were 2 triangles. Inside the 3-sided polygon, there was 1 triangle. Anybody think they can see a pattern, maybe, and figure out how many sides might be inside of a 99-sided polygon? Not 99, but you're the closest guess so far.
96.
How about 97? Right? So if this had 5 sides, we would subtract how many to get to 3? 2. So you go 99 minus 2. That means it's going to have 97 triangles inside of it. Okay? So the next one we're going to call an n-sided polygon. Has n number of sides. Okay, that just means you pick any number. It could be 1,000,005 sided polygon. Okay? The pattern is basically going to be whatever that number is, you're just going to subtract 2 from it. Okay, so if they give you some weird number like 37, how many triangles is it going to have? 35. Okay. All right. So now that we figured out how to get how many triangles you have in a polygon, we want to know what is the sum of all the interior